Hello, my name is John, and what we have here today is a quick study on gravity. More specifically, this study involves the combined gravity of the Earth, Moon, and Sun as they apply to hurricanes in the Atlantic Ocean. The hypothesis I used to begin this study was that when the moon and sun are closer together in their positions in the sky relative to the surface of the Earth's position, it has a greater effect on the creation, the linear movement, and strength of a hurricane. And I think I did find some correlation. I want to start by telling you I've been in law enforcement for 30 years. I'm not a scientist. I'm not a meteorologist. I'm not an astrophysicist. Astrophysicist. I'm simply a guy who has a curiosity about gravity, and I've done a lot of studying of gravity over the years, sort of as a more of a hobby than anything else. This, what you're seeing now, is an Excel spreadsheet. I have acquired the use of the Visual Basic for application language scripting in order to make an animation which will show exactly where the position of the sun and moon are at a given time. As you see here, over here on the right side, I have several hurricanes from the 2018 season listed as buttons over here, and up top here are some different areas that are going to be filled in as the animation goes forward. If I click on Hurricane Dennis, for example, what you'll see happen is the sun and moon appear to be rotating around the Earth's surface. We have the Earth here as a rectangle, non-moving. Actually, we know that the Earth spins on its rotation. But what I want to point out to you, I want to come down here and I don't know if you just heard that. At this particular point, I need to get the sun and the moon on there. Well, I guess it's not going to happen, but you can see that right over the Pacific Ocean, up here, we had a tropical wave. I'm sorry, this is the 2005 season. We had a tropical wave that started on somewhere around early morning Thursday, June 30th, 2005. At that time, both the sun and moon were fairly close together. This index up here, the sun to moon zenith difference index, shows the closeness of how close the moon and the sun were together on that particular time, a 0.7 out of a possible 0.99. 0.99 being the sun and moon are directly over each other. 0.0 being the sun and moon are on completely different sides of the Earth. So here we can see a 0.7, which means the sun and moon were fairly close together at that particular time. The moon distance index shows how close the moon was to the Earth itself at a 0.4. Of course, we know that the moon varies in its distance between the Earth and the moon. This index shows us, out of a possible 0 to 99, how close the moon is to the Earth. The closer the moon is to the Earth in its usual location, the higher this number will be. So this number is not particularly high. It's less than half its normal range. We have the moon arc index. This tells us how far above the equator the moon is, because the moon will also rise and fall uh, in relation uh, to the equator. So 0.74 is pretty high. That's 3/4 of its normal path. There's a variation also on how far above the equator that the moon's position will be, and that index tells us this. The sun's speed index is again uh, several. Uh, this index is just simply tells us how fast the sun is going uh, according to its variation as seemingly going. The sun doesn't evolve around the earth, we know that, but it gives us the index of how fast the sun is moving in relation to the surface of the earth, apparently. And 2.89 is really low. That means the sun is at its pretty much slowest movement right here when this tropical wave first forms. The moon speed index, in other words, the moon has different speeds as it rotates around the earth also, and that's pretty high. So we have a low sun speed index and a high moon speed index when the tropical storm that eventually turned into Hurricane Dennis first uh, started. So now we'll resume the animation and let it play out until the tropical wave turns into something stronger. We can see the moon and sun are pretty close together at this point. They're almost reaching a total zero. Okay, now they've reached 96, so they're almost on top of each other when the tropical storm turned into a tropical depression, which is a slightly higher category. And so we have a combined uh, we have a combined compilation of gravity from both the sun and the moon. And don't forget that the earth has its own gravitational field, so all three of those are in optimal position for something like a hurricane to begin forming. We'll take it slower now, and now we can see the tropical depression is now, this little red dot here is showing where the depression is at. So it went back down, or went back up to a tropical storm. It's just above South America at this point. The sun and the moon are absolutely above one another. It's as strong as you could possibly get. When these two are together or the moon is leading, we see this red storm move toward the left. But now the sun apparently is faster than the moon as it goes across, and the moon begins lagging, and so the separation between the moon and the sun gets greater and greater as we go along. And as the moon lags farther and farther back, this red storm starts going straight up rather than to the left, and that continues on. Now we're at we've already been through the hurricane section. It's hit land and it's turned back into a tropical depression. The moon continues to lag forward. As you see, the moon is now going below the equator to even further distance itself, and when that happens, the storm has a tendency in most cases to go toward the east as we move along. And then of course at the very end of the storm, it turns into a simple remnant low as it showers rain across the continental United States. Let's move this up to fast and get on out of here. And as you can see, the moon and sun gets farther and farther apart as the storm dissipates. And that's pretty much the the same as we go through each. Let's turn this down to medium so it slows down a little bit as we watch Hurricane Katrina. Now, Hurricane Katrina, this is 24 hours before the creation of the tropical storm, I think. I might put in a few days of before the tropical storm, so you can see the sun and the moon moving across the sky. Now here we see that the sun is always faster than the moon, and the moon is decreasing in its strength. It's going down. Now it's going back up. The sun is catching up to the moon. You can tell that by this the difference in their zenith points. They're getting closer. It's 28%, 29%, 30%, and it's moving slowly up. Right there we have tropical depression that just started on Wednesday, turned into a tropical storm. The sun is catching up at the 50%. This is a perfect storm, I believe, because the moon is leading the sun's gravity. Distance to the moon and the earth is very far away. And we have landfall, turns into the tropical depression, and then dissipates. So again, it's extremely indicative that the combination and the proximity of the sun and the moon do have some correlation to the creation, strength, and direction of a hurricane, and I think could easily be incorporated into some sort of early warning system, and even perhaps determining where a hurricane is created, which direction it's going to go, and the strength of the hurricane. Of course, this study is limited to just the gravitational pull of the Earth, the Moon, and the Sun. There's 100 other factors that are not included, in, which would involve wind speeds across the area of the Atlantic Ocean and along the western coast of Africa, which I think are important also in the formation of storms in anywhere in this area. You're going to have certain temperature differences across the Atlantic Ocean and nearer to the surfaces and coastal areas of these continents. So all of that has something to do with creation, and that would have to be also incorporated into any type of system we predict hurricanes. But this study is just on gravity, and as you can see as the animations go forward, there is definitely some correlation, at least with gravity. And once you can combine that, sister it with studies on temperatures, the proximity of the sun to the earth, proximity of the moon to the earth and to the sun, you have three different forces of gravitational effects there, which I believe are condensed when all three are in a specific proximity to one another. Now let's take a look at Hurricane Emily. Again, we have the sun preceding the moon for a couple of days as they travel. The moon is way low below the equator, and it's rising. The sun is catching up to it. We're currently at about a 65% strength of proximity, and it's Thursday, June 30th, 2005. We're in a 75, 77s, 80. We're up to 80 proximity of the sun and the moon. The moon is rising sharply above the equator at this time, and now it's even rising above the sun, which is falling southerly. And now we have a 93% tropical wave first formed when the sun and the moon were absolutely in line with one another, which was the greatest force of gravity there could be. And as we move along, uh, the moon begins to fall behind. Again, that's a common trait here. And we see this storm developing down here just above South America. And it's moving towards the right and a little bit to the left. I think that has something to do with the sun's position as it is relative to the equator. And it's moving leftward. We're hitting this part of Panama, whatever this is down here, south of the United States. It's going to the western part of Gulf of Mexico, and it fades out. Hurricane Irene, again we see the sun catching up to the moon from, we're at a 40%, around 40% moon zenith difference index right now. It's catching up. These are the days leading up to the formation of the Hurricane Irene, and and we see the sun catching up. We're at a 60-70% index strength. Tropical wave just began late Friday, early Saturday, July 2nd. It's moving. The sun is well above the equator. I mean, the moon is well above the equator, and the sun is just above the equator. And when the two combine, the sun and the moon are in the same alignment, that's when the tropical depression began. Tropical storm, as the moon starts falling behind, turns back into a tropical depression. Uh, and as the moon continues to fall and is above the equator, we see the movement of the storm is upwards and toward the left, and continues on in that fashion. The moon continues to lag behind the sun at a greater distance. We're down to about a 45 now, 40, and at that point, the storm begins to uh, take off toward the right, and actually back down and to the right a little bit here at this point. Again, that might have something to do with these temperatures along the coastal region. I'm sure those are involved in any prediction of hurricanes, but this particular animation focuses only on the gravity part, and I think it shows that gravity indeed does have a definite part in the formation of uh, of hurricanes. Here's Hurricane Wilma. We see that the sun and moon are well below the equator at this time. This is late in the season. It's October. We have a southern sun. The moon is lagging, way lagging, in the days come before the Hurricane Wilma forms. It just formed on Saturday, a tropical wave, and the sun and the moon could not be at farther distances. And I think this is one where temperature is probably going to be more of an issue, because as you see in this small area of water, which is surrounded by coastal areas of Cuba and all this South America, uh, those are going to be a lot warmer sources. So this is going to be a more temperature related uh, storm. However, I do think that the sun moving up on the moon is having an effect on the actual path that this hurricane is going to take. Um, being so far, the moon and sun being so far south, and during the course of the storm, you saw the moon rise. Let's play that again. Hurricane Wilma. The moon is rising from way down here upwards to above the equator by the time that the storm ends, and that indicates to me that it does have that this particular storm, although it was probably more temperature related, because we have a lot of coastal areas in this small body of water right here. Um, the direction of the storm, I think, is indeed affected by the gravitational pull of the moon, which is pretty close. It's very close at this point. It's up to 60% index the moon approximation to the Earth. So, and as you can see, it's going to the left as you would normally expect, because the Earth rotates clockwise to the right, and this storm is going to be lagging in its gravitational pull, just like the tides would lag. But here, what's interesting, you see the moon way above the equator now, and now that changes the course of this hurricane, which I think wants to stay in cooler temperatures. This coastal area is going to be much warmer than the path. Let's play that one more time. This coastal area is going to have warmer temperatures than this ocean area out here. And when this moon rises way up here, it got such a close proximity. Look at it here, we're at 80%. That means the moon is very close to the Earth, as about as close as it gets. And so the gravitational pull of the moon is much stronger at this point than it normally is. And of course, you see the storm kind of stagnate right here in this cooler temperatures, because they want cooler temperatures. It's in the middle of that pond, right between all these coastal areas. So, and then it finally, the moon is right above it. It's got enough force now to push that up out of this warmer area and into a larger body of Gulf of Mexico, where it's going to be a little bit cooler. Okay, you see the sun is continuing to rise, as well as is the storm. So gravity, and now it gets into this cooler area, it moves much faster because this is a lot cooler than it has been. So temperature does have a play in here. This study did not have anything to do with temperature. This study is only based on gravity, but I think that we can see from the animation of these 5 hurricanes from the 2005 season, definitely gravity is correlated to the creation, the strength of, and the movement direction of hurricanes. So I think that's important. I don't know how important it is. Like I said, I'm not a meteorologist. I am not an astrophysicist. But I have studied gravity for 30 years, and that's why I made this study. It was a study of gravity, not a study of hurricanes. Uh, I just used hurricanes as a way to fill out uh, the answer to a hypothesis, which is that the combined gravity of the sun and the moon can have an effect on the creation, direction, and ultimate strength of a hurricane storm in the Atlantic Ocean. Thank you for stopping by. I hope this has been of some help to you. If you're interested, go down here to one of these other sheets and show you all of the data that the macro pulls from. Here we have the zenith for the sun's latitude and longitude, and so when you see the uh, hurricane animation in process, that's where it's pulling all this information from. The zenith is that exact point over which the sun or the moon is positioned at, according to the Earth's surface. And again, I want to thank you for stopping by. I hope this helps. I don't know if it's important to the study of meteorology or astrophysiology, as it reports to the combined gravity of the Earth and Moon and Sun, but I think it does. I'm putting it out there. I'm going to be contacting some scientists to see if perhaps it might be of some use to them. I don't know. I think that perhaps there is some use in this sort of data that could help future predictions of storms, because we know where the sun's going to be and where the moon's going to be at any given point over any time in the future. Uh, that's the great thing about mathematics today. But again, thank you very much. I hope this has been some use to you. I hope if you're in the field that it's interesting. If not, you know, que sera sera. We do what we do and we try uh, what we can. Uh, Thank you again. My name is John. It's been a pleasure, and I hope that in some small way this can be of help. Thank you.